And welcome back. Now today we're going to be doing some work on the Raspberry Pi Model 3B Plus, which was released during 2018 and is a quad-core 1.4 gigahertz device with, I think it's 1 gig of memory on it. Anyway, the point is, that's what we're going to be playing about with, and there's something very specific that I want to do on there. Now, you may see next to it there, let me use my pointer rather than my fat finger, an ATtiny 85, and these two are going to be related very soon, assuming that it all works what I want to do. Because what I wanted to do and what I've spoken to Banggood about is that I'd like to demonstrate the UPS battery pack for this device. It's a cheap one. Now you can get battery packs, UPSs, for about, I don't know, £50, whatever that works out to in your currency, and frankly I wouldn't buy one for that price. I'm sure they're absolutely superb. Well, they are superb according to the reviews, but I would not spend £50. If it was a commercial project, obviously you would, or the most important project in your house, maybe, but I'm not spending £50 on a battery pack. The one I'm looking at is from Banggood, assuming I get it reasonably soon, otherwise this video is going to be somewhat short, and it's about £12 to £14 at the current exchange rates. Great. Alright, I've decided whilst I was editing I ought to really show you the product that we're going to be looking at in a future video, and this is the power pack here from Banggood. Now the current price is $12.26. I don't know what that's going to be by the time we get around to actually reviewing it properly, but it gives you a good idea of the difference in price between this and say the official Raspberry Pi power pack, which comes in at something like £48 or something. It's quite a bit, isn't it? But you can see it quite nicely on here, the way it just, it's a standard hat and just fits on top. Let's go back to that first image. Oh, click for a larger view. Yes, let's. There we are. So that's going to sit on top there and give you your pins back up. But this is just a battery pack out there. There's the power from the actual battery itself. Now, funnily enough, the power's not coming through the UPS here. It might be coming directly into the 5 volts up here. I wouldn't be at all surprised. A bit like we do it with the Arduino usually. If you're powering it from something else, you might do it like to V in, wouldn't you, rather than the 5 volt, making it go through a voltage regulator. I wonder if that's going to affect the operation of our circuit in any way. Well, we shall see, won't we? The problem is there's a known fault to the battery pack. It plugs into the GPIO headers here and sits on top, as it would do for a normal hat, hardware attached. Well, hardware attached, and that's what HAT stands for, and the lithium batteries in the middle. Now, I haven't got it yet, so I can't show it to you, and I don't need to show it to you yet because there's a known problem. The problem being that when you run this off a UPS, it doesn't know it's running off a UPS, does it? It just has the 5 volts delivered to it via the socket there, and well, that's it. All's well. Now, the trouble is when the power goes off, the UPS carries on delivering the 5 volts. Great, that's what you need. So this carries on running. Now, if the power comes back during that time, great, the battery starts getting charged again and the Raspberry Pi runs as though nothing ever happened. Brilliant. Except if the power goes off and the battery runs down enough to stop this, that is to say the operating system detects that there's now severe undervoltage. We've all seen it, haven't we? That little squiggle on the screen. You know, the lightning bolt that says undervoltage detected. Well, that happens at anything below 5.1. I think it's actually 5.08 according to my multimeter. But anyway, it will continue running, assuming it is running already, down to about 4.4 volts. After that, it can suddenly just die on you, right? And after that, it will not reboot. You cannot boot this up at 4.4 volts. It will start, you'll get the Linux messages and all that, and when it tries to go into the GUI, it just bombs and starts all over again. You get into a loop, basically. So, what are we going to do with this then when it dies? Because when the power comes back up, although the power has caused this to crash, you know, the Linux and the chip and everything else, it's gone. The UPS, of course, is still delivering power at that point, albeit at a reduced rate. The power then comes back, starts charging the battery, but this will not restart unless you disconnect the power. We've all had that problem. So this one, standalone. In fact, let's talk about this one. So this is a total standalone one now. If you connect up here, get it all running, and then issue a shutdown command from the GUI or command line, this shuts down, sits there consuming about, I don't know, 100 milliamps or something, quite a lot. And well, I say, you go, how do I restart that now? The answer is you got to unplug it or switch it off at the mains, let the wall wart die, and then switch it back on again, at which point it will reboot. That's no good though if this is buried in your wall or a beehive or your greenhouse or whatever it is. You've got one of these to monitor stuff. You're not going to run down there and try and unplug it. We shouldn't have to either. It's well, yeah, it's a design flaw, isn't it? But there should be something on there. As you can see on this prototype model here, I've actually got a reset switch wired up, or I had it wired up. I think it's disconnected now. Oh no, it's still wired up. Slightly neater job over here, which I'll talk about in a minute. So at least the reset, you can reset it while you're programming when things go terribly wrong. But there's no easy way to get this to restart. Now, if I zoom in on this like that, you'll see that there is now on the 3B plus a change in this little socket here. It says run and pen. Now previously that one where it says pen used to be ground, and the run, well, it should really be RST, reset. You short the run or the RST to ground and it resets it, which is exactly what this button here does. Okay, but the pen, which is power enabled, if you bring that low, because it's kept high by a pull-up resistor, if you bring it down low, it actually shuts down the power control circuitry, and your power supply will drop from about 100 milliamps to about 10, most of which is probably going to be taken up by the LED on here. You could desolder that, but or put a very, very low power LED in its place. But, well, soldering this board is, it's not easy, is it really? And these boards are expensive. So, but anyway, bringing power enabled to ground brings the power consumption down to about 10 milliamps. Without the LED, it'd be about 1 milliamp. And when you then release it so that the inbuilt resistor brings it back up again, the thing actually does start up again. So, with the UPS battery attached, if this has got so low that it's crashed and then the UPS starts up again, this will not start unless we do something with that pen, or indeed do something on the UPS itself, which I was going to do, but I thought, no, it's a common problem enough for the board itself to do. Let's fix this. So, how do we go about this? Well, there's a couple of ways. When you start up the Raspberry Pi, obviously you're going to get 5 volts at the pin up here, top right. And in fact, if I disconnect this little I don't know what you call it really, but it's a helper anyway. There we are. So if when it starts up, you get 5 volts on here from the USB socket here, and you can run a 3-line command as part of your rc.local to bring one of these pins down here, 26 or 21, or well, anyone really, almost anyone. 12 works, and to say as soon as you start up, bring that pin high so we can detect that we are actually running and haven't got into a shutdown mode. Fine. So I thought, great, well, that's easy enough. We can take one of those pins, the high value, well, high or low, and the 5 volts, use a bit of electronic logic. We can then perhaps pulse that pen pin, right, and bring it low for a second and then release it again. So I was designing away with transistors and logic gates, and it's just like, because what you don't want to do, the instant you decide that the pin is low here, that you should be high if it's running, you go, do I immediately reboot or just wait for 30 seconds because it might be in the process of booting at that point? How do we put a delay in with a logic gate? And before you start writing in and go, oh, you could have a delayed monostable and all that, I've been down that route. It's not quite as easy as it would appear. So I was hunting around the internet, and lo and behold, hit upon Tinkerman's site. Now, if you don't know Tinkerman's site, it's over here somewhere. Let's go to that. Here we are. This is Tinkerman's site. Tinkerman is a well-respected electronics contributor on the internet, and he's got lots of stuff on his website. I mean, it's well worth a read and bookmark this. I'll put a link, of course, in the bottom of the video. But he talks about a lot of stuff on here, and in fact talks about the very power pack that I've requested from Banggood, and he has acknowledged that there is a problem there, and his solution was basically to use an AT-Tiny 85. This is his little board. He's designed this board to have both a real-time clock, an AT-Tiny, and a couple of other components on there. But I thought, that's a step too far for me. I want the single responsibility type board. I will use the AT-Tiny concept rather than all my logic gates and whatnot, and well, just use basically what you see on the workbench here, right? Which is basically one of these little tiny AT-Tiny on a little board. Now, for demo purposes, I am using one with a USB connector so that I can just program it easily and connect it all up. If this were a proper project, I'd probably use one without the USB and then program this independently using an FTDI connector, which we covered in videos. That one there, that video there, we covered it, how to program an Arduino, which is the same principle. Okay, but it's up to you. This is small enough. Now, because it's small, I'm hoping that I can fit this either on the same hat as the UPS, or perhaps even on top of here. Look, I mean, I could attach that on top of there with a bit of double-sided adhesive foam or something. It's small enough, and just use a pin or two, perhaps the reset as well as the pen, just to control things. So that's the aim of this video, this first bit anyway, is to get this programmed, connected up to this, so that when this has got into a shutdown mode, this will detect that it's in a shutdown mode and go, ooh, problem, I need to give you a little nudge and make you restart. So how easy is that going to be? Well, you're probably ahead of me on this. It's going to be very easy, isn't it? I mean, the AT-Tiny 85 uses exactly the same code and IDE as the Arduino Uno, and the only thing you've got to detect is 2 pins on here, basically 5 volts, but then again, this wouldn't be running if you didn't have 5 volts. We'll detect one of these GPIO pins that we're going to set permanently high whenever the Raspberry Pi comes up, and then we bring one of these pins here, the pen basically, we're going to bring that low for about a second, and then release it again for it to to boot up. Now, because it's a microcontroller, we have all the logic we needed. We can say, I've detected the Raspberry Pi is not running, but IM, i.e. the AT-Tiny 85 is running. This should be running. It's not. I'll give it a few seconds, 30 seconds, a minute, whatever, in the same way that Tinkerman does, before we say, yeah, it's definitely not running. I'm going to try and help it along. So that's the aim, and well, I'm hoping that this could be used as a sort of a standalone solution just for the Raspberry Pi, and we'll attach this also when we get the UPS, and it should, well, provide exactly the same purpose. We might be able to make it slightly more sophisticated, because we could then detect on here via the analog port what the voltage coming in is by connecting it directly to the battery pack, which would be at 5 volts if it's being charged. But if we're running on battery, it's going to start deteriorating, isn't it? And as I say, once it gets down, I think it gets down to about 4.7 before the battery's going to die. But we'll experiment with that in a future video. Right, that's the aim. I've got to get, well, soldering a header onto here, a little bit of code. It's not very much. Tinkerman's site has his own little bit of code. I'll write my own. And Bob's your uncle. See you in a little bit. Now, something interesting happened today before I even got a chance to start soldering all this up. As you know, this is going to be the hub of my workshop automation project, so I can connect it to the Amazon Echo, turn on my heater, read the temperature and so forth. Except guess what? Today, September the, 26th, the Amazon Echo system across the whole of the UK just about is down. Who would have thought, hey, Amazon? I thought their services were, 100% uptime. Anyway, the Amazon Echo service is down. My Echo won't connect. I can't do anything with it whatsoever, which means if I'd already built all this into my workshop and was expecting the heater to come on from inside the house, I'd be severely disappointed, wouldn't I, really? And more to the point, if I then built all this in such a way that I haven't got override access to setting the heater or lights or whatever, it will be unpleasant to say the least. You'd have to start disconnecting things just to get your heater on. So that's made me think, whatever I do to this Raspberry Pi, using Node-RED and all the rest of it that we're going to use, I've got to make sure there's a physical override button so that this says, something on one of these GPIO pins has gone high or whatever mechanism we're going to use, and say, I'm just going to forget everything about Amazon Echo and just switch the heater on or off or whatever the case may be. Okay, who would have thought Amazon Echo would have gone down? Not just UK, by the way, apparently across some of Europe, Germany in particular, but there have been reports elsewhere as well. So, and one final thing before we get onto the real meat of this video. This Raspberry Pi, I was playing about with and doing all the various tests on the pen and the run pins and things like that. And I was measuring the voltage on the output of the pin when we run those 3 lines to bring the pin high. It doesn't use Python, by the way. You can just do it as a config, as I said. So I measured the 5 volts and it was something like 5.12, and I thought, well, that's odd that it's not closer to 5 volts. So then I tried to measure the 3 volts, and as I did so, as you can see with this pointer here, I slid it across here to touch the 3, and I touched the 5 at the same time, like that. Instantly it all went off, and we'll be holding a funeral service for this Raspberry Pi next week. No flowers, please. Donations to charity. Yes, it's quite a painful lesson to learn, isn't it? So if you're going to be playing about with these pins, first of all, don't. Not unless it's plugged into something. And the fact they've got 5 volt and 3 volt at the very top is, well, a poor design in my view. Or they could have put a diode in series with the 3.3, couldn't they? And just made it, 3.2 or something. It would still been plenty, I'm sure. But no, it died. Such is life. Right, soldering's done. There's the little AT-Tiny down here, all connected up, and I'll show you the circuit diagram of that. It really is simple. I've made it a little tiny bit more complex just for myself, really, to have this LED on here to show me when it's about to reboot. Because this AT-Tiny board, of course, does not have a serial to USB chip on it. What I said earlier about using this USB port to flash the code, forget it. I remember now when I started to do it and the Windows machine just goes, oh, I don't know what that is, I don't know what that is. I thought, oh no, I remember now. I had terrible trouble getting this working. In fact, I never did get it working because you have to install some Digistump drivers. And I remember a long time ago now, I had a go, failed, or it might have partially worked and it failed again. So I've given up now, basically. All these little tiny 85 things, I always program directly from either the AT-Tiny development board programmer thing. That's the video there on screen. That was quite nice. That did it well. Or just plug it into another Arduino. Use the Arduino as an ISP, which we've covered in some detail. If there's any desire for you guys for me to go through that, exactly how to program this in about 2 seconds, all right, 5 minutes, using an Arduino, you do have to have a spare Arduino, then I'll go through that in another video, okay? But it really would be quick. Of course, you don't have to. If you just want to prove the concept of all this and go, well, would it work? I want to see it working. Then, of course, you could substitute what could you substitute? You could substitute an Arduino Uno or a Nano, right, instead of an AT-Tiny. You'd have to change the code a little bit for the pin numbers, but apart from that, it would be the same. Okay, so that's an option for if you just want to, proof of concept, like, would it work? Oh my goodness, yes, it does work. Let me buy an AT-Tiny 85. Okay, now on that basis then, this AT-Tiny 85 with the USB socket, I can't quite work out what that USB socket would be good for. I mean, it must be connected to the TX plus or minus TX and RX on here, but how you'd use that sensibly with a USB socket, I don't know, perhaps one of you guys can tell me. Anyway, so we don't need that. So in fact, if you can find a development board without this, that's fine. Now the other one I had, which here we go, that one was exactly the same, a different layout of course, because you've got the 8 pins together, but that's just a plug-in AT-Tiny 85, which makes it easier of course to use the the flasher that I mentioned in that video, that one there again, yeah, because you can just unplug that Tiny 85, flash it, put it back in here, but then you're probably only going to flash it once, aren't you? So whatever. Right, we'll skip over this bit that we've managed to flash a sketch onto the Tiny 85. And so what's that? You want to look at the sketch. All right, let's bring that up next. Right, this is the very simple sketch I put together. There's lots of comments at the beginning here, right? So all this stuff at the top here, just read through that, because that also talks about the Raspberry Pi stuff you need to do. But I'll show you that as well, but at least it's in this sketch. Right, now if we move down, so basically we've got two pins up there, look, 1 and 0, because that's what we got on the Tiny, and we've got 0, 1, 2, 3, 4, 5. And also another one, which I belatedly added. This is the LED, right, to show me what's happening. Because we haven't got a USB to serial converter on there, we can't do any serial stuff, serial.println or anything like that. So what I've got here is an LED indicator there, right, that just outputs to an LED with a 150 ohm resistor on it. And okay, this sets various things up as high and low and all that. I'm sure you can read it as well as I can. Now, there is one gotcha. Right, I said we're going to sync the pin, the power enable pin on the Raspberry Pi, so sort of ground it via the Arduino and then release it back up again. And even as I was writing the code, I thought, that means we've got to set the pin as an output pin and set it high normally. Now, you've probably already seen the problem there. What we're going to be doing is presenting 5 volts to that power enable pin. Now, because nobody quite knows where that power enable pin goes to on the Raspberry Pi, because it's not an open source bit of equipment and they're not telling, right? Some people have had a go at reverse engineering it, and there's a reduced schematic set, which I'll also put underneath this video. But basically, nobody quite knows where that power enable bit goes. It controls the power rather than the actual chip itself. But I wasn't happy in putting 5 volts anywhere near that Raspberry Pi, not after my last fiasco. So what we're going to do is actually connect that pen pin to the Arduino via a diode, all right, reversed, so that the power from the Arduino cannot reach the pen, but when it goes low, the power can flow from the pen to ground. You want a circuit diagram. All right, here we are. Right, this is the circuit diagram, and I'm having to angle the board now to stop my fluorescent light shining on it too much. But basically, you've only got 2 components. So the Pi bit, we only want 4 pins, and 2 of those are power, which you can see there, right? On the Tiny 85, which is powered by those 2 power lines from the Raspberry Pi, pen goes to P0, but via a diode like this, right? So that the plus 5 volts here, that may be presented here, well, is presented here, definitely, will not reach here. So if in fact you were to measure the voltage here, you'd find it 3.3, right? Because that's what this is at. It's brought high by a resistor 1.8k. There's also another resistor, I think it's a 3.3, that goes to ground. Okay, you can see that on the partial schematics that they've released, but that's about it. Now GPIO 21 is the pin on the Pi that is brought high as soon as the Pi starts running, and I'll show you how to do that. And we're just reading that into P1 on here. And on P2, move it across, that bit there, so P2 goes to a light emitting diode via 150, and this lights up whenever this thinks, oh, it's time I started the reboot process, right? In other words, counting down from 30. All right, I'll show you the rest of the code now, because I think that's pretty easy, isn't it? I'll put a picture of this up as well. It'll be much easier to see. So that was the circuit diagram, and pretty simple it was too. And what this does here then, this bit here, it will just sets various pin modes up, you know, input, output and so forth. And scrolling down, there's the loop delay. So what we're going to do is count to 30 seconds when we discover that this Pi high pin, GPIO 21 I've chosen, but you can choose a different one, is not high, because if it's not high it means the Pi isn't running. So what it does then, it says, oh, Pi's not running. Have I counted to 20 seconds? If I have, bring the pin low for 1 second, bring it back high again, reset the loop counter and reset the LED. Right, so it's no longer on. When the LED's off, it means everything's okay. Okay, yeah, so all the rest of it here is just about saying, well, it's not 29 seconds yet, or everything's okay. And we must reset the count here, because say for example that pin went low just for 5 seconds for some whatever reason, right? If we didn't reset the counter at this point here, the next time it went low, it says, oh, I'm already at a count of 14 or something. Well, 5 seconds in that example. I'll start counting from 5 up, and before you know it, you've reached the 30 seconds. The instant it goes low, it'll try and reboot it. So that makes sure it's reset. And then we're looping here every second. It just makes the coding a lot easier, don't we? So once a second it clocks round and can add 1 to that count. So that's the code, and jolly simple it is too. Obviously this will be on my GitHub, and you can download that and have a look at it, but it really is quite straightforward. Okay, now you want to see it in action? Of course you do. Okay, let's flip back to the work bench and have a look at the actual Raspberry Pi window then. Right, it's running at the moment. The LED down here is not on, which means everything's fine. The Raspberry Pi has brought that GPIO 21 pin high, so the ATtiny says nothing to do, frankly. The pin's high, I don't need to worry. So what happens then if we deliberately shut down now the Raspberry Pi? So we have a shutdown process. This then effectively shuts down the process. GPIO 21 there will go low and the Pi is dormant. Well, that's not a state you want to be in, of course, if you are monitoring greenhouse, nuclear power stations, or bees in your beehive. So let me bring up a window with the Raspberry Pi on it. There we are, there's my Pi. Now all I'm going to do, let me make it a little bit bigger for you. All I'm going to do is issue a shutdown, and what you need to do is look very closely at that LED. Right, so here we are, and we're going to choose shutdown, which will shut down the Pi as you'd expect. Shut down, off we go. Now it's trying to restart the VNC server because we've lost the connection, and as you can see down here, the LED is on. And I'm just going to actually shrink that window with the Raspberry Pi on it, because you can see some activity at the back there with the green flashy, but probably about now, doesn't take that long to shut down, it's down. Now what you'll see is this green LED after 30 seconds just flash off once for 1 second as it brings that pin down to ground, and then of course because that GPIO 21 still isn't high at that point, it will come back on, but by then the Pi will start booting up. So all we've got to do is wait for another probably 10 seconds or something like that, and that will flash. Don't worry, I'll edit the video just to make this a bit quicker if we have to. And there you saw it, right? So it's brought the pen down now, and you might see some flashy work at the back here of the rod. There it goes, there's that green light. Now that's proof really that something's happening. Basically it's trying to boot up, and hopefully the VNC server, that window top left, will automatically reconnect. Normally it's pretty good actually, I must admit. Now whilst it's booting up, of course, the Arduino is saying, oi, that pin still isn't high, I'm going to start counting down. But now the Raspberry Pi has booted, obviously, or at least enough, brought that pin high. Everything's all right as far as the ATtiny is concerned. It's not going to do anything anymore. So we just give it a couple of seconds for VNC to reattach, which means the GUI's up. There it is. And lo and behold. Marvellous. Brilliant. It works. Hooray. Yes. How do we bring that GPIO 21 pin up? Well, there are instructions in the sketch for the ATtiny, but I think it's probably worth having a closer look, isn't it? Right, that's next. Right, you've booted your Pi up, right, and you're just sitting looking at the GUI like this. So if we open up a terminal window, so it's that one there. Oh, how many did I open? More than one? Doesn't matter. Right, the first thing to do then, I've used a different keyboard now, so this could be slightly tricky. So here we are at effectively your home directory, normally, if you've set up your Pi that way, but it doesn't matter. We want to go, though, from the root down to etc directory. So cd /etc. And in there, we want to edit the rc.local file, which is, it could be a hidden file. So you might not actually see it if you use the file explorer. But anyway, you need to do it in super user mode. So sudo, I'm going to use nano because well, it's the one I know really. Sudo nano rc dot, oh dear, don't blame me, blame the keyboard. Right, sudo nano rc.local. So we're doing super user do nano, that's the editor, rc.local. And there it brings up the file. Now normally this is all the file that there is, where it says this file does nothing and there's this little IP address thingy. But if we scroll down the bottom a bit, there we can see some bits I've added. So these bits here, right? Now I've tested it on 14, 26 and 21 pins and they all work, but I chose eventually pin 21. So basically, I mean, the first line there, that one there with the export on it, it says, what it's saying is, I want to use pin 21, please. Well, that's it. I want to use pin 21. The second line, this one here with the direction, we're saying here, I want that pin to be an output pin, please. Right, that's the direction of it, input or output. And finally, that third line says, I want to put 1, the value of 1, on that pin. Oh yeah, see it says GP21 there and GPI21. And of course the first line it says 21 over there. They've all got to match. So if you change it to 14 or 26, you can't just change that first line on there. You've got to change it both here and here. Otherwise it won't work, of course. And that's it. That's all you got to do. And you'll find if you put a multimeter on there. No, don't put a multimeter on there. You'll probably blow the thing up like I did. It will just set that pin height even before you get into the GUI. All right. Very simple, very easy. Bob's your uncle. And that's about it really. So that gives us a way of preventing the Raspberry Pi ever getting into a state where it's powered down but hasn't rebooted. Now normally that would only ever happen if either you did it deliberately, of course, or if you had a battery pack on there, a UPS of some kind, which is what we're going to be looking at next time. So this circuit is going to be an awful lot more use once we get that that battery pack on there, and it sits directly over here, nice and neat with the battery on it and everything. It'll be a lot more use when we get that on there, because then when this does, or if this does ever switch off due to low power, but the battery is continued to be charged, this will ensure that the Pi will reboot itself. Now, if this was mine, and sooner or later this is going to be my little Arduino power-up system, whether I stick with this actual physical board or not, I don't know. Maybe I will, just to use it up. I'd make it a little bit more sophisticated. I've already used one LED here to show me when things are happening, just to prove it does work. If I disconnect that that top wire there, this is the one it's monitoring. So if I disconnect that, oh look, the light goes on straight away. Now if I don't reconnect that within 30 seconds, the thing will reboot. So let's connect it back up, and there we are. So okay, I've got one LED, but remember, because we can't use any serial commands for the debug window while you're running it, but in a real life situation, you wouldn't be using serial prints anyway to do that. You'd have a monitor, you know, a little screen or something, or more lights. And as you've got more pins, you could do it, but hold fire on that, because a couple of these pins, you can read analog stuff. As you can see, 3 and 4, you can read analog. And we might want to do that, mightn't we, for reading voltages on battery packs or something, as well as the I2C capability of that battery pack to say how much have you got left in your capacity. But that's for another day. This, though, I think stands in its own right as a Raspberry Pi rebooter, or perhaps restarter. A rebooter is just the one that's connected next to that pen down here, which is the run pin, and that's what I've got connected up over here. If I turn it around, see here I've got a little tiny switch connected up, glued on there basically. If I turn it upside down, the board, you'll see that it goes to one side, that one goes to the run over there, and that one just goes to ground. And I tried to make it as neat as I could while it's on this plastic mount. Just makes things a lot easier, isn't it? So if I press that, it will immediately reboot it. What do you mean you want to see it? Right, let me bring up the Raspberry Pi again then. In the top, there we are. So it's running. Now if I press this, it's going to, well, it's going to kill it, isn't it? So press. Oh look, the light's gone off straight away there, which means, well, it's dead really. It's in the process of rebooting as we speak. Over here, I can't do anything on here, because this is just an image now. VNC has just got a snapshot of an image and can't do anything with it. But well, you saw what happened. It's dead easy to do. Everybody does it. Even in the old models, the pre-3B plus, that used to be the run, used to be the reset, and that used to be a ground next to it. But now they've changed it on the 3B plus to make it a PEN, power enable pin. Right, okay, that's rebooting, but we don't have to see that. We know it's going to work. Oh, there we are. Look, that was quick, wasn't it? Huh. Right, stay with me tuned then for the next video. Well, might be the very next physical video, but certainly very soon, about the battery pack that we're going to stick on here to make this absolutely UPSable. Well, and with this, what could possibly go wrong? Ha! Comments under the video, please do give me a thumbs up, because YouTube likes it when you give me a thumbs up. And comments as well. Whatever, queries, comments, opinions, I don't care. I try now. I used to say I respond to absolutely every single one. With the volume of comments increasing, I try to respond to every single one. You might get a canned response like thanks for posting, something like that, but at least I've read it. Okay, I do absolutely read each one. So thanks for that. I love your support. It's really great, and I love doing these videos, so we'll keep going. Thanks for watching, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.